Hello. Oh, have you found another one? How did you know that was there? Sit. Good boy. Hey.
How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have a brake component in off a 992 loader that needs to be repaired. So what this actually is a brake anchor. This houses a lot of the braking components that is attached to the diff, and it is hydraulically controlled to actuate the brake so the machine can stop safely. And the problem with this one is the bleed nipple that is used to bleed the air out of the system so the brakes work correctly has been damaged. And what it looks like is the bleed nipple has seized in there and someone has attempted to remove it. They did try to drill it out, but they did damage all the rest of the threads, so they were unsuccessful, and that means this part is inoperable. What we need to do is try and salvage this component by doing a thread repair, so we're going to get it set up in the mill. So there are a couple of ways I could set this up on the mill. I could lay it flat and use a 90-degree head, but the way I'm going to do it, I'm going to mount it vertically using angle plates. And that way I won't have to feed the bed into the 90-degree head. I'll be able to use the quill, which will give me a lot more feel and control. Now that I've got the part mounted and level, I'm going to turn the turret around to get the head in position. Because of how heavy the component is and all the weight is going to be set on one side, I am going to hook the crane up to it just as a safety measure. And no, my mill is not bolted down, nor are any of my machines, because of how much the concrete moves throughout the year. First thing I'm going to do is find center, but because that hole is damaged on one side, I'm not going to be able to use that as a reference. So what I'll do is touch off on the sides of the hole that are in good condition and find center of that axis. So we know the offset of the hole position, so what I'm going to do is touch off on the other good side of the hole on the other axis. Then I can move the bed to 3.155 mil, and that will put me in the center of that hole. And that's definitely going to be good enough. This part isn't being attached to a rocket and being shot into outer space, so if I'm a little bit out of center, it's not going to be a problem. Now that I've got that set up, I'm going to use a 12mm end mill to go down and clean out that hole and remove all those damaged threads and hopefully remove the rest of that bleed nipple. Back in the hole.
Oh.
So we've successfully drilled out that hole and did manage to remove the rest of that bleed nipple, and the hole is nice and clean and all the threads are removed. But I'm just going to go a little bit deeper to remove the rest of the seat that the bleed nipple seals against, because the repair sleeve will have a new seat machined into it. Next step is to drill that out to 14.5 mil, which is our tapping drill size for an M16 repair sleeve. And I've chosen that size because of the amount of material that are on either side of the bolt pattern on this housing. There wouldn't be enough room to put a larger repair sleeve in there, because that would then jeopardize the integrity of the part. Bend the edge on it. Now I've got that drilled, I'm just going to chamfer it before I tap it. And to tap it, I'm going to be using a Goering M16 by 1.5 thread pitch gun tap. Righto guys, so that's our hole prepped. Now I need to make the repair sleeve, and to do that, I'm going to be using this. This is an M16 cap head bolt, and these make perfect thread repair sleeves. So we're going to get it set up in the lathe. Now that that's set up, I'm just going to machine it down to the correct length to fit the hole. Now I'm just going to chamfer the end to suit the profile of the gun tap so it bottoms out in the hole. Now I'm going to center drill it, and I'm going to use a 5mm drill to drill 20mm deep, and when this is finished, that will be a passage for the oil to bleed through. Now that's done, we're going to turn it around and get the other side drilled for our bleed nipple. So that's all the lathe work completed on our repair sleeve. I'm not going to tap it just yet, I'm going to wait till it's installed in the housing. To ensure that this seals correctly, I am going to be using an O-ring under the repair sleeve and also Loctite so it holds it in place and won't come undone.
O-ring.
Leave the O-ring out. Squeezed it. So that didn't really go to plan. When I was installing the repair sleeve, I did manage to pinch the O-ring. So what I'm going to do is countersink that hole just a little bit more, and that'll give that O-ring somewhere to go. So that worked out, our repair sleeve is installed and tightened into the hole. Now I'm just going to give it a little bit of time for that Loctite to completely cure before I finish it off. Drop it, drop it, drop it, leave it, sit, stay. Righto guys, so that Loctite has set now. We can go in and machine down the head of the bolt, and to do that I'm going to be using a 1-inch 4-flute end mill. So I'm not going to machine that head down any further because I do need some material there to retain that O-ring. Now that I've done that, I'm going to chamfer the hole and then we can tap it. And the tap I'm going to be using is a 7/16 by 20 TPI to match the thread on the nipple. So that's all the work we need to do on the repair sleeve. Last thing I need to do is fit the bleed nipple. So that fits in there perfectly, and for the sake of a couple of hours work and a $4 bolt, our customer is able to get this $6,000 component back into their machine and put it back to work. So now we can get this off the mill, back on a pallet, and get it back to our customer. Thanks for watching. Like my hammer, because I broke the other one.
Oh my god. Have you not got any new ones yet?
No.
Curtis's hammer still hasn't fixed it.
It.
See what? Air.
And to tap it, I'm going to be using a Gurine And to tap it, I'm going to be using a Gurine M16 by 1.5. Me. And to tap it, I'm going to be using a Gurine M16 by 1.5 thread pitch to tap the hole.
Can't tap.
Fuck. So what we need to do is try and salvage this component. So what we need to do is try and salvage this component. I thought I was going so good there'd be no fucking bloopers in this. Because of how... I had it. Because of how... Oh, I did it again. So what it looks like is it...
Yeah.
Oh, fuck me. What the fuck was after that? Help.
No. But?
Right, what? Right, so what I'm going to... should I start again?
Yeah.
No.